Welcome to the Code of Entry podcast, where we cloud the issues with facts and help you upskill to stay on the digital edge. Here's your host, Greg, with the latest.
Hey team, Greg here with another Code of Entry podcast. I'm joined by Keri Fischer. She's actually mostly going to host today. I think this might end up being a roast session, but we're going to talk about terminology in the technology and data space. And with that being said, I'm going to turn it over to Keri.
We all like to hear your opinions on various topics, so I'm excited about this one.
If I don't know the definition, I'll make it up and hopefully everybody rolls with it and it's a new definition.
I don't think it's about accuracy of the definition. It's about your feeling and your reaction when I ask like the different terms. And then, yes, that's the best part for me. That's what I'm looking forward to.
Okay, so maybe definition, but emotional reaction. I can do emotional reaction.
Okay. So the focus for today's podcast is really going to be data science terms.
Okay.
Data science terms that maybe you like, maybe you don't like. And then recommendations maybe. If you don't like them, what would you say what would that term really be? Or maybe some of them are outdated and they should be modernized. And what does that look like?
Okay.
So, being the subject matter expert on data, we'll start with big data. What is big data?
Big data. Yeah, most people that think they have big data
don't.
You don't have data. So big data generally is when you have too much information to process on a single machine. Whether that's technically correct or not, doesn't matter. If you can do it on one machine, you don't have big data. If you can do it on one server, you don't have big data. If I can spin up one instance in AWS, I don't have big data. So if you start looking at it, you could use AWS Snowball Edge Compute optimized, and you could get that. You could get what? 40 terabytes?
Yeah.
You can get 40 terabytes on that one instance. That's one drop shipped server to your door that can gather, prepare, store, and use data. I can arbitrarily think the line for big data is actually pretty big. The next thing, if we're not doing pure size or on a single computer, is just going to be something that traditional mathematics will not scale on. So I think a lot of times in the past, we've been working with academia and labs and they'd be like, hey, there was this math algorithm that came out in 1979 and it solves this problem perfectly. Yes, it does on 100 problems at a time. I need 1 million a second.
Yeah.
It never catches up to where you are, so that becomes unfeasible. So I think that's where you end up with in the big data space. There used to be the 4 Vs and then there were the 5 Vs. You had volume, veracity, variety. What's the last V?
There's velocity. What's one?
Velocity, volume, veracity.
You had
variety. Yep. So there's the 4. The 5th V that ended up getting added, which I really liked, was value. So you needed to have value in that data. So the 5 Vs, the one machine requirement, throwing out a machine example of that kind of compute Snowball Edge or an Azure Stack Hub, whatever you're using. So yeah, I think that's where I would look for qualifying what big data is and how it's useful. So if you've got big data, you should probably be using, I'll say Python today. It hasn't always been Python. You used to need to use Scala, so you could use Spark, but then PySpark came out. So if you need to do large computations quickly, you need to parallelize it, you need to use Spark, which replaced MapReduce. MapReduce is still good for some uses.
Yeah.
But yeah, so big data.
Do you feel like that or how you feel about that now? Do you feel like it was the same in 2014? What is big data?
Yeah, no, absolutely not.
Like 10 years have gone by. What is big data? What would Greg say in 2014?
Yeah, in 2014, Greg would have been like, oh yeah, that's definitely like a few hundred gigabytes, and I can't do it in Excel. If I can't do it in Excel, then it's big data. That's, definitely not true. But again, skewed by perspective now.
Perspective of big data.
Yeah.
All right. Next one.
Okay.
See how it's about data, but it's going to be data wrangling.
Data wrangling. Get out of the room, Miss George Mason University. All right, so you mentioned the 2014 thing. Yeah, if we were in the late thousands or early teens, data wrangling is a perfectly appropriate term. If you were to come into an interview with me for a data science job and say that you were good at data wrangling, I would know that you had come from academia and had no practical experience, and it might be difficult to get you applied to doing the work and not thinking about the work. Or maybe that's my big data lens again, but generally your data cleansing, your data munging, your data wrangling, anything that you're going to use to talk about data that's not, I'm going to normalize, standardize data, I think you're talking at an elementary data understanding level. You're not at kindergarten like most folks. It may be middle school.
Okay.
But you're not at even the high school level of talking about data. When you start talking data, you said munging or wrangling? Which one? Wrangling.
Wrangling.
Either one. All right. In theory, data wrangling is taking the data once you have it and transforming it from a raw form to a form that's usable. So I call that processing data. And when you process that data, you might be doing enrichments. You might be doing transformations. You might be doing normalizations. But data wrangling is way too generic a term. And I would, again, say that maybe you hadn't continued to do continuing education in this field, because I think it's a dated term.
Okay. Data lassoing.
Next.
Wrangling. Okay.
Next.
That's not real. Just
Yeah.
making stuff up because it's wrangling, like rodeo stuff.
Yeah, I did the 8-second ride on data. Okay. We were talking about the data rodeo. And then
That gets you a belt.
belt buckle.
Yeah.
I only know about that because of watching Yellowstone, so we can keep going.
Oh, you didn't watch PBR
No.
back in the day?
Mm-mm.
Living in Georgia? Got to be surrounded by cowboys.
I'm in Georgia now. I was in Virginia then. I had no idea what a cowboy was. Okay, other than the Dallas Cowboys, who I hate because I'm a Washington Commanders fan.
Everybody hates a cowboy.
Yeah, it's cool they can't win in the playoffs, so it's all good.
It's okay. There's lots of memes about it. Then you don't have a reason to break your TV for watching Cowboys.
That's true. I can be happy during the playoffs because my team's not there.
That's true. That's true. All right. So a data term that you like then, data cleansing. Yes or no?
No, it's borderline. I mean, it's not as bad. I think it's a different category because you sometimes do need to cleanse your data, whether that's a way to deal with outliers, do the proper transforms. I think it's a term that's a little less specific when you're not sure what you need to do, or you have a class of data that's going to require a few different steps. So I think data cleansing is still okay.
Okay.
Yeah.
I had a problem with data cleansing just in general when you get your samples back, and if it didn't have the information in the right field that you wanted, you just drop everything else.
Yeah, I mean,
insane.
Yeah, there's definitely ways of data cleansing that can bias your results. But I think in general, it's sometimes data cleansing is going back to getting more data. It's getting more entries. It's getting more samples. It's transforming fields because somebody, when they were supposed to rate something 1 out of 5, rated it 1 out of 10 or something like that. But I still think cleansing is a consideration, but the cleansing techniques, some can be questionable, yeah.
So you talked about going back and get more data. So data mining. What do you feel about mining for data?
Okay, data mining still as a term, I'm not sure I like it. It has an implication to a company for me now, talking about data miner. If you're looking for real-time reporting of news things in the world or on social media, data miner, okay, good use. You're looking for threat reporting across the world, yeah, absolutely not. Don't waste your time. That company has a niche, so it has a connotation to a company for me. Of course, they name themselves after the term for a reason.
Yep.
But yeah, data mining just means I'm doing data exploration. So I go back to just saying, hey, if we're still in the world of using these imprecise terms that made it easy for people to start talking about data, I just get the impression that you're not current, because in the current world, we have a lot of data professionals, and I don't put you as a data professional using those terms. Yep, yeah, maybe one-off talking to a client or whatever, but I don't be like, yeah, we went data mining and we found, okay, were you spelunking too?
Yes. All the time.
Yeah, and spelunking's a cool hobby, but I'm not doing it for data.
What are you doing it for?
There could be cool rocks. You get down on like Luray Caverns and stuff. Maybe it's a cenote, so you get to go get in the water. I don't know.
I don't know what that is. I'm from the Midwest. It's flat.
Okay, this is unrelated, but if you ever go down to Cancun, you can go to a cenote, which is like a underground river. So you like go down in the ground in this cave and you get in the water and it's super clear. It's cold. Sometimes they'll have lights and then they'll turn off the lights and have like your guide will have a flashlight or whatever. Cenotes are super cool.
Okay.
So for your next vacation, by the way, not a paid endorsement or advertisement. All
right. Data warehouse.
Okay. Data warehouse, good term. So I think the interesting thing is as data terms have evolved, the data lake became the data warehouse, became the data lake house, and a lot of folks start arguing between the terms when they could really mean the same thing. The data lake that you created in the mid-20 teens could well be a data warehouse, but that term wasn't really the term yet. Could have been a data lakehouse, but that term hadn't been made up by like Databricks yet. It could have been a data fabric, but that term wasn't made up until COVID. It could have been a data mesh, but that book wasn't written until a couple of years ago, and a couple of people read it and decided it's now data mesh. So I think you get in the slippery slope anywhere between having a data lake and a data mesh, that the terms become interchangeable depending on when you started in the industry. And so sitting here today, now data lake has this connotation that you're just collecting all the data. It sits there. You haven't done anything to it. Okay, that's not what we did, but we called it a data lake because that was the term. Okay, great. So now you're looking at a data lake being something like your S3. Then you're looking at something like your data warehouse being somewhere where it's been prepared for use. So we get that gather, prepare, store. In that store phase, you end up with kind of this area where that you're now gone from a data lake to a data warehouse, right? It's categorized, it's on a shelf, it's somewhere, it can be used, it can be pulled off. Then you end up with, on the other side of data, you end up with the data lakehouse effect where it's like, hey, we can hold even more types of data and we can access it even more ways. I don't really buy into the lakehouse term other than the pictures that they started making of the lakehouse was exactly what we did for our data lake, which ended on me with the soapbox of, okay, data lake, data warehouse, data lakehouse, same. Like my data fabric, data mesh, same. It just depends on who you ask and which cult you're in today.
Yeah. I feel the lake is more flat and open to availability. And when I hear warehouse, I feel like there's stovepipes. And there's pipes in a warehouse somehow. And that the usability and availability is just anti.
Yeah. Well, we talked about it before, right? I like this idea of your data being south of a line where there's an API, and that API allows you access. The API is the surface of the water. I'm okay having a data lake. But as soon as you have a data warehouse, again, I think that comes back to too many people having their hands in the pot over what the data store should be versus a data engineer architecting it so that the data is rapidly available to analytics and applications.
Okay. Then how would you bridge it to the data mesh, data fabric part?
Yeah,
you have lots of lake houses everywhere?
Yeah, no. So you go back to, okay, what's a data lake? And I think a data lake implies big data. So there are a lot of people with data lakes that don't have data lakes because they don't have big data. When you start trying to do a hybrid deployment model or a decentralized deployment model, which by the way isn't great for big data analytics. So you've got to find this balance of being able to bring the data together to have data locality, to do big data analytics and get a result in a timely manner versus a hybrid model where you get, and it's normally a cost trade-off, right? Where I keep larger data at the edge because it would be too expensive for me to bring it all back in one place. Or maybe it's too specific, it's geographically bounded, whatever. There's data laws, GDPR. Hey, I don't want to take it out of Europe. I want to leave it at Europe. And so you start getting into data fabric when I can reach to other nodes and see the data and interact with the data. And then data mesh, in my mind, the only real difference is that you have standards across those nodes, that the data is available in a documented way. I'm going to go back to that API layer, and that there's some governance over it. So if you go back to like our data fabric deployment in our last job, that data fabric was a data mesh all day long, no question in my mind. But that book hadn't been written yet. We wrote implementation policies and everything else without that book. And we didn't even call it a data fabric because data fabric wasn't the term yet, right? but it was our hybrid deployment of the system, creating a common data operating system, using it at echelon, right data at the right place, using it forward when appropriate, being able to remotely access it. So I think that's where you end up going from, hey, data lake, big data level, maybe enterprise level. You have regional nodes that you can access remotely. Maybe it's more granular. You pivot down to those from the enterprise. You use them locally if you're not at the enterprise. And I just think that the API structure and the governance and stuff is all implied in that. So data fabric, data mesh, same to me.
So describing the at echelon pieces, how would you describe how to employ analytics at those echelons?
Yeah, so that's the trick, right? If you deploy analytics and you use analytics at each of the locations and then aggregate the results to make a decision, I think you're skewing your view. You're using math to support math, which never turns out well. I think if you're doing a query remotely where you're saying, hey, send me all of information type A, and then you're processing it together, you're in a much better place. I mean, for an example, there's this old adage of death by 1,000 paper cuts. Okay, that's great. If I go to each location and there's something anomalous or malicious, but it's below the noise barrier and it's, oh, that only happened once in a 72-hour period at my location, not a big deal. We blocked it, nothing to see here. Okay, great. Then you're going to take a report from all of your locations that says, hey, nothing to see here, we're good. Whereas if you pull it all back together and you get all the events together, you might see that the same IP address has hit everywhere in your company network, the same time in the last 2 minutes. And that's a much more significant thing than each location saying, oh, that thing wasn't a big deal. It's just a normal scan or whatever. But you can lose a lot of perspective that way. So it needs to be interrelated. Okay, maybe you have more specific data and it tips and cues something to the enterprise that you can look for and you can try to find a way to look at it from the enterprise or with a different data set. Or you see something in a different data set and you can pivot down and you can look everywhere. So it's just, you've got to have the ability to do both, where you can dig deep in one site or you can look broadly across your enterprise or you can miss something.
Okay. So we did it at the different echelons, right? What level would you do the modeling, machine learning, deep learning? Which?
Yeah.
From the warehouse part, the lakehouse part, what are we talking?
So I'm talking training it at the enterprise level. So whatever term we've used, we'll say that it's our data warehouse or whatever, right? Wherever our central repository is, our largest body of knowledge, if you want to do artificial intelligence, you have to give, I'll just say the machine, you have to give the machine the opportunity to learn your data, because the whole point is that people don't know. So if you predispose the system to, oh, hey, only these 5 things are important, only these 5 things, you're missing the opportunity to find relationships that people didn't know. Therefore, you've already biased the algorithms. You're not going to have kind of the full learning potential. So if you do it forward at the sites, like the actual training of the models, I don't think you're going to have enough information. And if you do it that way, you're going to have to train it at every edge location because they're all going to look different. They're all going to be different. Whereas if you do it at the enterprise, you can identify those things. You can identify the trends by location, the seasonalities, whether it's by location or just by time. And you can have an enterprise view, but then you take those models, you deploy them at the edge once they're made, and then you try to run them at the edge for low latency. You run them at the enterprise in case you have to have all the data together for something to work. And then you have this multiple kind of layers of execution because we want redundancy. And then some things will work well centralized. Some things will work well at the edge. Some might do both. But yeah, I think you almost always try to create the models centrally and push them down for execution.
So with all the different terms, what if you didn't have your warehouse, your data, your lake house, your data lake? What would be the first thing you would tell somebody to start out with if they didn't have a common location to view it, say from a global perspective or from that area?
I guess that you need to start gathering the data as soon as possible, whether it's usable or not, whether you know what the next step is or not, because you can't go back in time for data that you didn't collect. So we'll go cybersecurity. If there's a big intrusion, There's a 0 day that hits. There's the next SolarWinds or some Microsoft Exchange server or whatever. You can't go back and look at when that happened on your network, what you need to remediate or whatever, if you weren't collecting that data. If you were collecting the data, even if it's in cold storage, you can at least warm it up and look back in time. So I think it's starting to collect the data. And by far the cheapest way to collect the data is to put it into AWS S3 cold storage. And I'll throw it out there, right? Like, I'll generally recommend AWS. I think AWS is a dominating alternative over the other cloud providers. I think there are some exceptions, right? If you have exquisite compute needs, maybe you go to GCP, Google Cloud Platform.
Yeah.
If you have some Microsoft Office integrations you really have to have, or Azure Active Directory, even though you can run that in AWS, you might want to go to Azure. So Azure Blob or AWS S3, just start getting the data. And I'll go back to one of the things I said about big data. A lot of people don't have big data. Just start to save it somewhere. And when you start to run out of space, get more space. And the cheapest place to get more space is going to be in the cloud.
Okay. So I'm going to go into, you have the data sitting at your, say, your global view, right? What would you describe as a difference between business intelligence or other visualization efforts for that data?
Yeah, I don't think there's a big difference. And I think it just becomes the nomenclature that's used in different industries. So the business intelligence of cybersecurity data versus your financials, they both have a significant impact on your business. The visualization tools generally don't care what the data is. They're all going to do graphs and some time series or some donut charts or pie charts.
I love donut charts.
Yeah. Heat maps.
My favorite.
They're all going to be the same general visualization, speedometers. And it'll go back to applying the domain expert to the information. Now, depending on where you go, there might be pre-done out-of-the-box visuals that are ready based on the tool. But look at something like Kibana and Elasticsearch. You can make a time series graph based off stock prices or a time series graph based off of your log data on the temperature that your CPUs are operating at. I think it's really the nuance between the data that you're feeding into the visuals, not the visual tools. Can I go back in time? I remember I got a chance to meet with Secretary McCarthy a few years ago, and he was like, hey, y'all are doing this system X and you're doing all this data. Why can't I do that for my BI data? And I was like, you can. There's no reason you can't. You just have some senior folks that have a preference for a vendor, and that's what they want to use, and it costs a lot more, but there's technically no reason. So it goes into, okay, great, business intelligence. You should be doing things for intelligence. We want to have an understanding of data. Once you have the data and you make the data useful, that use is to inform a decision. So that information is hopefully intelligence as being, whether it's a business driver in the terms of money or a business driver in terms of cybersecurity, which honestly should be money. We talk about how a lot of C-suites don't have CISOs and all that kind of stuff. Hey, just watch the news. Shout out to AT&T last week. I hope you have cybersecurity, right?
Yeah. So for
software update, yeah. Good luck with that.
Yes. Just do security updates. Mm-hmm. Don't pay attention to the solar flares either.
Yeah, okay.
So what if I'm looking at different tools I want to use for visualizations or BI tools for business intelligence? Should I be on the lookout for ones that actually are doing AI as well? Yeah.
Loaded question.
Isn't it?
Okay.
There's yes and no, I think. Maybe not.
Yeah, it depends on what you're doing. I think the answer on AI today is drastically different than AI. Last year, I literally would have laughed at you and said, if they say they're doing AI, they're lying to your face. I say that on the podcast all the time. But today, if it's got generative AI kind of baked in, it allows you to ask natural language questions of your data. Now, someone needs to have trained it, but there are a lot of companies that are integrating it. And I think you have to look now, because if you're looking at a tool that doesn't have some flair of AI, even if it's just a prompt that you can type a question into and it can recommend where to look, you're working with a company that hasn't picked up and modernized like they should have. So I think they're on probably shaky footing in a business, even if they have the best user interface right now. I don't think they've put the investment into RDT&E that everybody else has. So their research budget is not high enough. So yeah, I think AI is a must. Now, you said visualization builder though. Okay, there are a lot of visualization builders where you don't need AI, but you're going to have a training barrier difference between your users there, I think. So 6 one, half dozen the other. On the visualization itself, I think a lot of times summary statistics are appropriate. You don't need any advanced analytics like artificial intelligence, which is actually a banner that goes over a whole bunch of different advanced analytics like computer vision, machine learning. Yeah, so all over the place with AI was like, hey, software product should have some AI baked in, even if it's just almost like a recommender or natural language processing of a question to a query. But as far as like the visuals themselves, I wouldn't always say you have to have an AI visualization, right? Well, one of the ways I try to explain why I'm good at data science is because I know when to find the answer between, hey, I could use AI for this, or guess what? I can use addition for this. So sometimes old school summary statistics, old school, right? The math, arithmetic, it's perfectly appropriate. I want to do a count. Awesome. Filter, great. It can still, give you an answer to a question. So I think it's all on what you're trying to answer, how complex it is, and what the use case is. So on one side, AI essential to selecting products to do more advanced things. Our normal, usual charts and stuff are still perfectly appropriate to try and inform answers.
So you have maybe some folks evaluating tools that have AI, right? What's the value proposition, do you think, for someone to actually select it? Like you talked about, it has to work on data that's been trained. What if they don't have access to that type of data? Or like, how would you go through evaluating that?
Yeah, so I think it's a little easier than it used to be because training on data, if you look at OpenAI right now, you can make your own plugins really easily. You can customize plugins. You can go to SageMaker and you can retrain a lot of the popular models. You can just go use them as they're configured in Amazon Bedrock. Amazon Q lets you link to your Microsoft OneDrive now, and it'll review all of your company files. Okay, great. I got into the preview, so I got to play. And you can give it access to your OneDrive business files, and then you can ask questions and you can create chatbots to inform your business. So I think training for a specific industry, if you're doing kind of normal business intelligence functions, think average employee reading and synthesizing information, game changer. You're going to change time. You're going to save time. You're going to make your employees more productive. You're going to take away from a lot of very manual tasks. I think when it becomes interesting is when you're doing things that require a subject matter expert to apply the art to data. That's when you really have to pay attention and have somebody look and be like, hey, does this give us answers that make sense? I saw a picture that had been generated in a Facebook group that I was in. I dated myself because it was Facebook, but it was a Facebook group and they're like, hey, is this generated by AI or is this a picture in my backyard? And it's a really good picture, but it's little stuff, right? Like it was this outdoor kitchen setup. There was no way to get into the inside. Okay, that's an indicator that it was probably AI. The grill was facing the wrong direction. It was facing the outside, which it would be if it was designed a different way, but it was facing the outside of the kitchen instead of the inside of the kitchen, right? Oh, that wouldn't work either. One of the bar stools was like off the concrete in the back in the wrong spot, but there was a bar stool. So it's just, you've got to make sure that you take a SME, apply it to it, and make sure that it works for you. And if not, there are ways that you can retrain it. You can leave the base model frozen and you can add new layers on top. That's the cheaper way to do it. Or you can go retrain the whole thing. But if you're not sitting there from a Fortune 100 company listening to this, I don't recommend it. You just want to add some context on top of the already frozen layers of the models that exist today.
All right. It's good tips and tricks from Greg. If you were a sis, what would you do?
Oh, step 1, get a cloud browser because users are the devil. You didn't really ask that question, but I had to.
That's just for protecting the network, yeah. If you were the CEO, what would you do?
I would hire us as consultants.
Perfect.
But, okay.
Yes. All right. My last one.
Okay, last one.
You talked about it earlier when we were talking about data cleansing and bias. Do you have any recommendations? One, what is bias? right? Based off the data, but then recommendations of countering it, different ways or techniques, whether it's cybersecurity use cases or other use cases. Any thoughts?
Yeah, bias is a tough one because the bias can be caused by the data. It can be caused by a person. It can be just caused by not updating your model through time. So the bias is a pretty broad topic. So I think one of the first things is we went back and I was like, data cleansing is borderline. I think you just have to make sure that when you make an analytic or train a model, that the data you have isn't biased. And that means that, hey, I'll go the racial use case, right? Hey, I don't have only one entry for an Asian American and one entry for an African American, but 1,000 entries for a white American. Guess what? That's not a statistically significant sample to use for your model. So you need to go get more data.
Yeah.
On the other side, it's, hey, sometimes outliers are really what you want, and you have people that'll clean data by chopping off outliers. It's like, hey, guess what? Those outliers, the anomalies that you need to detect. So you need to consider, what are you going to do? Maybe you're going to oversample. Hey, take those outliers and put them into the data set 1,000 times, or create synthetic data that represents outliers like that so that you have anomalies in your data set so that you aren't training 1 million benign points against 2 anomalies, right? You might need to oversample in your data or cut some of your benign cases out if you just have too much data, which would be a great problem to have. But there's different ways to deal with the bias. Maybe you do some clustering to make sure that you've got your feature engineering right. You're using the right features. Maybe you do like a principal component analysis to identify which features are important. Hey, don't cut features that you don't think are important. Let the machines tell you. Do a PCA, figure out which features are important before you start trimming. So I think it just comes back to taking that holistic approach to understanding the data that you have and whether you have enough and what your gaps are so that you don't start from this fragile position that's easily breakable. And then the next thing is, once you have a good model, throughout time, you're going to have users, and hopefully there'll be some reinforcement learning or something to keep your model up to date, or you're going to retrain. It's just making sure that you check in on the model occasionally and saying that's still accurate, and that if it is updating itself and learning, that it's not learning the wrong thing and you're introducing more bias that way.
At what level or talent do you think can handle that responsibility?
Yeah, good luck. You've got to find somebody really good. I was looking through, again, some of the AWS statistics on certificates, and it's something like the Solutions Architect Associate is the most coveted one, and that one has a 72% fail rate. And then you go to the Solutions Architect Professional, you have the security one. Supposedly the hardest one is the machine learning one, and they don't give you any statistics, and you just look online and people are like, yeah, if you don't actively do machine learning as your job, you're not going to get it. It might be something short of that particular certification or whatever, but it's not an entry-level employee, and it's probably not a mid-level employee. This is somebody that you're going to have to pay to do this, and it can't be their first experience because you need the domain expertise. You need the holistic understanding of how the system works and how the data interacts. So between the data science background and the domain expertise, at least the person that's going to lead that team is going to need to be pretty special. And then, yeah, you can have different parts of the team that are more junior. There's going to be some oversight and they'll learn and you'll be able to grow more capability, but it's going to be a really hard job to fill, I think.
So deliberate investment is what I'm hearing you say.
Yes, absolutely. If you plan to get into the world of AI and machine learning and not just go buy a product, and you want to be able to do your own stuff or audit and trust and retrain your own, then you have to have a deliberate investment of who's going to lead that team, and then probably to give them a significant budget to hire the kind of the bedrock elements of that team. Then you can start get some entry level people and do some OJT and whatever, but you have to have a significant deliberate initial investment to get that started.
Those are my terms lexicon overview questions. You didn't even have any
Boom.
bad reactions except to one. I was expecting more.
All right. That was good.
That's good.
Thanks. All right. Awesome. So there was our quick rundown on some data science terms. Some other ones that we could have hit would have been like, oh, let's talk about deep learning or convolutional neural networks or predictive analysis. I'll just say, hey, get familiar with AI in general and what AI really means. AI has several categories of advanced analytics underneath of it, like natural language processing, deep learning, machine learning. Maybe get familiar with that because AI by itself doesn't really mean anything. And I'll say most people, when they say AI, they actually mean automation, which isn't the same in any way, shape, or form. We talked about data warehouses, APIs we've talked about several times here on the podcast, but that application programming interface, an easier way to get to elements of information in your data stores instead of requiring people to know exactly where to query in what type of data store. Put an API in front of it and have them ask for an element name. And after you've normalized, that'll make it so there's a lot more information available to them. And yeah, I think that's all the big stuff. I appreciate everybody. Keri, I appreciate you grilling me there. By the way, She didn't tell me the terms before.
That's why it's great.
Yeah, so thanks for that.
You're welcome.
And hey, until next time, keep hustling.
Thanks for listening. Find us on social media at Code of Entry and online at codeofentry.com. Check back for new episodes or join the team by signing up for notifications. Until next time, keep hustling.